So this was a pop quiz 12, which was related to bonding and structure questions. In the first, sodium, magnesium, aluminum are metals. State what is meant by metallic bonding. So you have to define the metallic bonding. What is metallic bonding? Metallic bonding is an electrostatic attraction between the lattice of a positive ion or a positive ion and the delocalized electrons. So it is electrostatic. The term electrostatic, whenever we talk about force between the charges, we call that force electrostatic. So electrostatic attraction between the positive ions and electrons or the free electrons. That's known as a metallic bonding. Then melting temperature depends on the strength of a metallic bonding. Explain why the metallic bonding in magnesium is stronger than of sodium. So when we compare the ions, like sodium ion is there and it is attracting the delocalized electron, and there's a magnesium ion and it is attracting the delocalized electrons. Their isoelectronic means because sodium having 11 protons are there and 10 electrons, and magnesium is having 12 proton and 10 electron because it lost two. So as a result, there is a stronger, greater nuclear charge, so more attraction to the valence shell electron. So strong force will be there. But in sodium, it's a weak attraction. It will have a weak attraction. So how you write in terms of points, the points you will include. First thing, when we move across, the size of the ion decreases, like it gets smaller. So the first point we'll mention, like magnesium ions are smaller in size, and magnesium ions have more electrons in the structure, like because one magnesium loses two electrons where sodium loses only one. And magnesium is also having a higher charge density, you can also say, or a nuclear charge. As a result, smaller size and a greater nuclear charge result in a greater attraction towards the nucleus. So the points which will score the marks, the magnesium plus 2 is smaller than Na plus 1. The second point is lose 2 electrons compared to Na, which lose 1 electron. So there will be a, and it has a, magnesium plus 2 is having a greater nuclear charge. So all these things, what will happen? They will result in a strong attraction. So it has a stronger attraction towards the nucleus to the valence shell electrons. So these are the points you will mention whenever you want to compare the strengths. Same thing, they can ask for why aluminum, the next element is aluminum, why it's having a high melting point in magnesium or sodium. So same answer is there, but the smaller size charge is 2 plus, losing more electrons, stronger nuclear charge, as a result, stronger attraction. In the element silicon, phosphorus, sulfur, chlorine, atoms are joined by covalent bond. Describe the attraction between the atom and the covalent bond. So, what is actually, like, what kind of attraction is there? Even a covalent bond is also electrostatic attraction, but what happen in a covalent bond? Covalent bond is actually, like example, say we have hydrogen. So this is a nucleus of one hydrogen which is having one proton. This is a nucleus of another hydrogen, one proton. and they share the electron between them. So what is actually a covalent bond? Covalent bond is an electrostatic attraction between the shared pair of electron and the nucleus. This attraction is called a covalent bond. So describe the attraction between the atoms in a what kind of attraction? So that is also electrostatic attraction between the shared pair of electron and the nuclei of the bonded atom. So covalent bond is also electrostatic attraction between the shared pair and the nucleus. Explain why the melting temperature of a silicon is much higher than phosphorus and refers to their structure. Like silicon, it has a tendency to form a giant covalent structure. Where phosphorus is there, it will form a simple molecular structure. So, first thing we'll mention for a silicon, it will have a giant structure, but for phosphorus, it will be a simple molecular structure. And as a result, what will happen? Simple molecular structure, there is a weak force between the molecules. But in a giant structure, there's a strong covalent bond between the atoms because we don't have molecule. So there are strong bonds, covalent bonds. So as a result, what will happen? We need a greater amount of energy to separate these atoms from each other as compared to that in a phosphorus. So as a molecules have a weak force, so we need a smaller amount of energy. That's why the silicon melting temperature is much higher than phosphorus. So this was a pop quiz which was related to bonding and structure.